Coming to the types of fuses, we all started with, I think we do have still rewirable fuses. This is one of the oldest one uh, in the fuse types of fuses, the rewirable ones. In my childhood, I used to have them in my homes also, and my domestic applications also. But even now, if you go to some sort of industries or educational institutions, you still find rewirable fuses. So now we will discuss about the types of fuses. We'll start with the rewirable fuses, and next we will move on to cartridge fuses, and next we will move on to the latest PTC fuses also. So the first of its kind is the rewirable fuse. You can see this is a rewirable fuse. You might be seeing them at your homes. If your home is old enough, some 30 to 40 years old, you might be using still rewirable fuses. Or if you go to your grandparents' home, then you can find these things. These are simple rewirable fuses which are still being used in homes and old offices and government offices might be. They just consist of a carrier and a socket. So this is your socket and this is your carrier, and here there will be a material. So the current flows through this one and into this one. This is the way how the current flows. When the current is high enough, then automatically this one will be blowing off. So again, you remove this one and you bind a wire here. Okay. So again, you put it back into action. This is the simplest form of a fuse. We call it as a rewirable fuse because the wire can be rewired anytime. So when the fuse is blown, the carrier is taken out, rewired, and put back in the socket to resume normal operation. Once upon a time we used to use them, but now we are not using them. But still in larger applications, we still use these rewirable fuses. They are very cheap and very simple in construction, but not reliable with modern fuses now. The second one is a cartridge fuses, most common types of fuses. These are available in different types and shapes. Here you can see that there is a glass envelope, and there are two metal caps here. These are the metal caps, and this is your fuse material. It is placed in your holder. See, your glass envelope is very clear. So this is directly placed. Even in electronic equipment, even if you see in your DMM also, or in some sort of kits, you will be using this cartridge fuses. So the current comes, flows, and goes on. If there is any overcurrent, then automatically this material, it gets stripped off. You need to replace this cartridge fuse. See, the glass envelope is very clear, so it is transparent, right? So you can see whether the fuse is blown or not. Whereas in rewirable fuse, it was very difficult for us. So this is one of the cartridge fuses. There are two types. One is a slow blow fuse. The other one is a fast blow fuse. The slow blow one, it has a larger element that can handle overcurrent for a relatively short period of time. And normally it is unaffected by spikes in appliance. Whereas fast blow types of materials, types of fuses, they react very instantly. The name itself indicates that they are fast enough. Any current spike is there, they will react immediately. Now, I'll show you these things in the laboratory and the class today. The cartridge fuse and the rewirable fuse today. And the last one is a high rupture capacity fuse. This is one of the widely used fuses nowadays. This is a Siemens model which I found on the internet. See. HRC fuses we call them. These are a type of cartridge type fuses, which consists of a transparent envelope made of stickite, magnesium silicate. It is filled with a quartz powder. Normally, there are two types. You can have solid material inside, or you can have liquid material also inside. Normally, a type of mineral oil is poured if it is a liquid type of fuse. If it is a solid type, you use quartz type of material. So this will automatically act as an arc extinguishing agent. So whenever, as I already told you, when you are trying to open the circuit, there will be an arc. So arc extinguishing material will be there inside. So that's why they are used for very high fault currents. If you do have a very high fault current, if you try to open it suddenly, there will be an arc you need to extinguish. So defaultly arc extinguishing materials are present inside this one. Okay. So they offer wide advantage like clearing high as well as low fault currents, not deteriorating with age. They don't deteriorate with age, and they have very high speed operation and provide very reliable discrimination. These are the advantages which are offered by HRC fuses, and that's why they are widely used nowadays. And the latest trend is resettable fuse or a polyfuse. As the name itself indicates, they are resettable, self-resetting fuses. They consist of this carbon black particles which are embedded in some sort of organic polymers, and the presence of carbon makes this mixture a very conductive mixture. So when a large current flows, heat is generated which expands the organic polymer. So the carbon black particles are forced apart and the conductivity decreases to the point where no current flows. It is just like I do have a polymer and I am using some carbon particles. See, I am using some carbon particles. Okay. Now, when there is a high current, then automatically what happens is this thing will expand. So this thing will expand. So what happens is your carbon material also will expand. So when it expands, its conductivity decreases. Thereby, see, when the current is high, it will lead to expansion of your organic mixture. When it expands, then your carbon material also, they are forced apart. When they are forced apart, automatically what happens? The conductivity decreases. Conductivity decreases, which means current decreases. When current decreases, now the problem is solved. When your current is high, now ultimately what you are doing, you are trying to decrease the current. When the current decreases again, automatically what happens? The process comes back again. So when the current decreases, your material will cool down again. Then automatically what happens? The carbon materials, they come closer and the conductivity becomes to normal. So this is a type of automatic resetting. Okay. So the conductivity is restored as temperature decreases. So you don't need to physically replace the fuse every time when it is blown up. So this is also called as a PTC, which means positive temperature coefficient. If the temperature is high, then automatically the resistance increases. If the resistance is low, the temperature decreases. We call it as a positive temperature coefficient. And that's why these resistors are, these fuses are called as PTC fuses. Okay. They are normally used in computer bus supplies and mobile chargers. Okay. Because we don't need to replace them all the time, they will be directly inside the things. So in that case, even if it is costlier, no need to replacements, we will use these things. We can't open the things again and again and we can't replace them. In that case, we better use PTC even though they are costly. Okay. And that's why they are used in aerospace devices also. Okay. So with this, I hope that you have understood what the different types of fuses which you might be encountering in your laboratories till your final year. So the conclusion, an electric fuse is a safety device which is used in electric circuits and also electronic circuits to protect them from excessive current. It is designed to break the circuits, stop the flow of current, and in this process, it protects your equipment from further damage. There may be an arc which will be formed in the front. You should take care of that. You should extinguish it. And there are different types of fuses available in the market. The choice, it depends upon the user and also the application. Okay. So with this, I hope that now you are able to describe the need for fuse, list the types and their applications also. So this is a question for you. So you should get me a note. What's an electric fuse? What are the requirements of a material? Suggest at least 2 materials that can be used as fuse materials. And what is the reason for selecting them? That I think I have given them already in the PPT. You can go through them again. You answer the questions and see. Second question is, what are the desirable properties of fuse? List the different types. and compare their functions and mention where they are used. This is also you can find on the PPT. Apart from this, there is a third question which I am giving you as a homework. You identify the fuses where they are there at your home. I think you might be seeing MCVs mostly, but still, if you find any of the fuse, get a picture for the class and we will discuss about that in the class. Okay, thank you.